Hey everyone, Miss Anselmo here with a tutorial on matter. We'll start by describing the properties of matter. Another way to think of properties of matter is to think of them as just characteristics or descriptions of that matter. Some examples of physical properties of matter include color, seen here, density, which is the mass to volume ratio of a substance, and solubility, which is the ability of a substance to dissolve in a liquid. The state of matter refers to what state of matter the substance is in. So for example, if it's a solid, a liquid, a gas, or a plasma. Melting and boiling points refer to the temperatures at which a substance melts or freezes and the temperature at which a substance boils. A few more physical properties include luster, malleability, ductility, and conductivity. Luster refers to a substance's shine. Malleability refers to whether or not a substance can be pounded into thin sheets. Ductility has to do with a substance being able to be drawn into a wire. And conductivity has to do with whether or not a substance can conduct heat or electricity. Another word to use instead of conduct that might help you better understand it is transfer. All four of these properties tend to be properties of metals. Metals have luster, they're usually malleable and ductile, and usually they're good conductors of heat and electricity. Chemical properties are a little easier because there aren't as many to remember. The ones that we're going to be most concerned with are flammability, which is the ability of a substance to go into flames or burn, and reactivity. Reactivity is a pretty open-ended statement. Reactivity simply describes the ability of a substance to react chemically with another substance. Physical changes are any changes to one or more physical property of matter. In a physical change, the chemical identity of the substance remains the same. One example of a physical change is any change to the shape or size of a substance. This could include cutting a piece of paper, crushing a rock, or slicing a loaf of bread. All changes of state are also physical changes, so any change from a solid to a liquid, liquid to gas, gas to liquid, liquid to solid, all of those are examples of physical changes. And finally, any type of dissolving would also be considered a type of physical change. When you can dissolve salt in water or sugar in water, dissolving those substances is just an example of a physical change. Chemical changes are different than physical changes. When chemical changes occur, the identity of the substance is changed and a new substance is formed. This is the result of a chemical reaction. When I teach students about chemical changes and chemical properties, I tell them to look for the keyword react. If you see the word react in an example, the example must be talking about some kind of chemical property or chemical change. There are several signs or things to look for when you're trying to determine whether or not a change is chemical. These signs include a change in color, a change in odor, any bubbling or fizzing you might see, if a new substance is being formed, if there's an emission of light or heat, and if the reaction cannot be reversed. One example of a chemical change is rusting. There are several signs that tell us that rusting is a chemical change. First of all, there's a change of color from a metallic color to a rusty color. Additionally, the actual rust that's being formed, that orangey red crumbly material, is a new substance. Another example of chemical change is burning. Signs that burning is a chemical change is that there is an emission of light and heat. There's generally a change in odor. There's definitely a change in color, and a new substance is being formed, usually some kind of ash. Baking a cake or any type of cooking is usually also a chemical change because you end up with a new substance. The last example of a chemical change is food digestion. When food enters the body, it gets chemically broken down and changed into a new substance. Since new substances are being formed, it's a chemical change. One of the physical properties we're going to look at with more detail is the states of matter. There are 3 states of matter shown here, but really we know that there is a 4th as well called plasma. The ones pictured here are solid, liquid, and gas. Solids are substances that have a definite shape and a definite volume. Liquids are substances that have an indefinite shape, meaning that they take the shape of the container that you put them in. Liquids do, however, have a definite volume. Gases, on the other hand, have an indefinite shape and an indefinite volume. That means that they don't keep any shape, and they also will expand to fill whatever container you put them in. A plasma, which is not shown here, is basically the same as a gas, but it's superheated and the particles of a gas are ionized or electrically charged. Other things to consider with the states of matter would be how the particles are arranged, how they move, and how much energy they have. Solids have particles that are very close together. The particles are also vibrating in place, meaning the particles are in a fixed position and don't move out of their position. Particles also have really low energy in a solid. Once you move to the liquid state, the particles are still pretty close together, but at this point they're able to move past one another, which gives a liquid its ability to flow. The particles in a liquid have more energy than the particles in a solid. Finally, when you move over to gases, the particles are very far apart and the particles are moving rapidly. They also have the most energy. We're also going to look at how states of matter change from one form to another. Looking at this diagram, we can see a summary of the various phase changes. If we're looking at solids, solids can change into liquids, and when solids change to liquids, we call that melting. Liquids can then also change into gases. When a liquid becomes a gas, it's called vaporization. We learned in class that there are two examples of vaporization. Evaporation and boiling are both examples of vaporization. We could also move in the other direction when a substance gets cooler. Gases can become liquids through the process of condensation, and liquids can become solids by the process of freezing. There are also some more unusual types of phase changes. When a solid becomes a gas and it skips the liquid phase, we call that sublimation. There's also examples of a gas becoming a solid and again, skipping the liquid phase. That's called deposition. Along with being able to identify phase changes, we're also going to need to know some information about specific temperatures. At the top of your screen here, you see that we have solid again, liquid, and gas. In between solids and liquids is a temperature called freezing point. The freezing point, which is also the same as the melting point, is the temperature at which a solid can become a liquid or a liquid can become a solid. So it's the temperature at which a substance freezes or melts. On the other side, we can see that there's also a boiling point. The boiling point is the temperature at which a liquid will begin to become a gas, also the temperature at which a gas will begin to condense into a liquid. So we have freezing points and we have boiling points. At the bottom of this screen, we can see that we have specific temperatures for water. Water melts and freezes at 0 degrees Celsius. That is something that you're going to be expected to know. Additionally, water also boils at 100 degrees Celsius. So the melting point and freezing point of water is 0, and the boiling point of water is 100 degrees Celsius. We can also look at phase changes in a graphic way. On this graph, on the y-axis we have temperatures in degrees Celsius, and on the x-axis we have heat being added. If we look at this graph and we read it from left to right, on the left bottom corner we see that we would have the lowest temperatures. So this diagonal line here represents a solid substance. At this temperature here, the substance begins to melt. If we're adding heat, the substance is melting. One thing that you need to remember is that as a substance melts, as I move across this graph, I am adding heat and adding heat and adding heat. However, the temperature of the substance remains the same. When you add heat and a substance begins to melt, the temperature remains the same until the melting process is over. Once the melting process is over, the temperature of the liquid can increase and increase and increase. So on this diagonal line, we're representing a liquid. Once the liquid reaches this temperature here, the liquid has reached its boiling point and the liquid will begin to boil. Again, during the boiling phase change, we see that the temperature remains the same. Once again, the temperature of the liquid will remain the same until the boiling process is over. and then the temperature of the gas can increase. Notice down here during this phase change, we have melting and freezing. The only difference would be if you're adding heat, it would be melting, but if heat's being removed, it would be freezing. Same thing up here with the boiling. If you're adding heat, we would call it boiling or vaporization, and if heat is being removed, we would be experiencing condensation. Two key words here to remember with phase changes is the word exothermic and the word endothermic. Exothermic describes changes where heat exits or leaves the substance. That's our little trick. Exothermic, heat exits the system. We also have endothermic changes where heat's entering the system or heat's being absorbed. When you have an endothermic change, the substance gets hotter. And again, we use that trick. Endothermic is when heat enters a substance. So looking at this diagram again, we can identify the different phase changes as either endothermic or exothermic. Again, endothermic is when heat enters a substance and the substance gets warmer. So melting would be considered endothermic, and vaporization would also be considered endothermic. Exothermic is when heat is exiting a substance and it is becoming cooler. So condensation and freezing would both be considered exothermic changes. Looking at this graph, this is the phase change graph for water. We can notice that in between points A and B, we're down from minus 100 degrees to 0 degrees. So from points A to B, we're looking at solid water or ice. From points B to C, if we're adding heat, the substance is melting, or if we're removing heat, the substance would be freezing. Since we're talking about water, note that this is happening at 0 degrees Celsius. So if we're adding heat, the substance is melting from points B to C. Once the substance is completely melted, then the temperature will start to increase. Remember that during the entire phase change, the temperature remains the same. In this case, it would be 0 degrees Celsius. From C to D, the liquid is getting hotter and hotter and hotter, and the temperature is increasing. At point D, the substance reaches its boiling point. Again, since we're talking about water, that temperature is 100 degrees Celsius. From points D to E, the temperature remains 100 because the substance is boiling. Throughout the entire boiling process, the temperature will stay at 100 degrees Celsius. By point E, the substance will have completely vaporized, and then from points E to F, that's demonstrating the water vapor getting hotter and hotter and hotter. We can also look at a phase change graph of an unknown substance, and a lot of questions can be asked here. For example, you could get a question like this. At 40 degrees Celsius, what state of matter is the substance in? Looking at the graph, 40 degrees Celsius is right here, and when I look at where my line is, I can tell that at 40 degrees Celsius, this substance would be a solid. Remember, this first diagonal line represents the solid state. So at 40 degrees Celsius, this substance is a solid. We can also note that at point B, which would be about 70 degrees based on this graph, the substance will begin to melt. Between points B and C, the substance is melting. So the melting point of this substance would be 70 degrees Celsius. You could get a question that asks, according to the graph, what is the melting point of the substance? And based on the information I just went over, we would be able to determine that it is 70 degrees Celsius because of where line BC is. Another question that could be asked, at 100 degrees Celsius, what state of matter is this substance in? At 100 degrees Celsius, we see that we're on this part of the graph, which is the liquid state. So at 100 degrees Celsius, this substance is a liquid. Finally, you could be asked what the boiling point of this substance is. We know that boiling is occurring between points D and E. So if we look at the graph on the side, we see that that is happening at 140 degrees Celsius. So the boiling point of this substance is 140 degrees. That's all we have for matter today. As always, thanks for watching.